In today's lecture, we will discuss a system of conics. System of conics. So first of all, we discuss that if you are given any five points in the plane. If you are given any five points in the plane x1, y1, x2, y2, x3, y3, etc., then only one conic can be drawn out of these 5 points. Passing through these 5 points, only one conic can be drawn. So how do we show that? So the equation of the conic is ax square plus 2hx5 plus by square plus 2gx plus 2fy plus c equal to 0. Suppose this is the general equation of the conic. Then if you divide it by the constant c, then this equation can be written as if you divide it by c, then this equation of general conic can be written like this. Now this equation has how many constants to be determined? Alright, to write the equation of this conic, you need to find out this 1, 2, 3, 4 and 5 quantities. So if you know the value of these 5 constants, then you know the equation of this conic. So that means to find the equation of the conic, we need 5 conditions. We need 5 conditions, alright, 5 equations which are independent of each other. So if you have 5 points, say x1, y1, x2, y2, x3, y3, x4, y4 and x5, y5, alright, and suppose we have this equation, let's call this as A1, this as A2, this constant as A3, this constant as A4 and this constant as A5. Then if this conic passes through x and y1, you put x and y1 here, x equal to x1 and y equal to y1, you get one equation in A1, A2, A3, A4, A5. Also, if this conic passes through x to y2, then you put x equal to x2 and y equal to y2 in this equation, you get another equation in A1, A2, A3, A4, A5, and similarly putting the coordinates of the point x, this and fifth point. So you will get 5 equations in A1, A2, A3, A4, A5. Alright? And if no 3 points of these 5 points are collinear, alright, then you get 5 equations in A1, A2, A3, A4, A5, and solving those 5 equations, you can find the values of A1, A2, A3, A4, A5, and that will give you the unique conic passing through those 5 points. So given 5 points, you can find the equation of the conic which passes through these 5 points. But the condition is that no 3 points of these 5 points should be collinear to each other. So this was the first article, first fact that we have discussed, that you can make a conic pass through 5 given points. You can make a conic pass through 5 given points. Next is intersection of 2 conics. So suppose you have one conic and suppose you have another conic. So this conic is s equal to 0 and this conic is s dash equal to 0. Suppose the conic s is this and the conic s dash is a dash x square plus 2h dash xy plus b dash y square plus 2g dash x plus 2f dash y plus c dash equal to 0. Suppose this is the second conic. Now we want to write, consider these points where these 2 conics meet. These 4 points are the points where these 2 conics meet. We want to find out the equation of all those conics which pass through these 4 points. We want to find out the equation of all those conics which pass through these 4 points, which are the common points of the conic S and the conic S dash. So consider the equation. Consider the equation S plus lambda S dash equal to 0. Right? This equation S equal to 0, this is a second degree equation in X and Y. The equation S dash equal to 0 is also a second degree equation in X and Y. Now this equation S plus, suppose lambda is a constant, alright, then consider the equation S plus lambda S dash equal to 0, S plus lambda S dash equal to 0. Then you will observe that this equation is also a second degree equation in X and Y. So this equation is a second degree equation. Second degree equation in X and Y. So every second degree equation in X and Y represents a conic, hence represents a conic. So this equation represents a conic. Now what we observe is that what about these points? These points lie on S. Alright, these points lie on S and they also lie on S dash Y dash. So all these points A, B, C, D, these 4 points lie on S as well as S dash. So any point which lie on S, they make S equal to 0. The common points of S equal to 0 and S dash equal to 0 make S plus lambda S dash also equal to 0. Those points which satisfy S equal to 0 and those points which satisfy S dash equal to 0. That means those points which lie on S as well as on S dash. All those points which make S equal to 0 and which make S dash equal to 0, all those points make S plus lambda S dash also equal to 0. So that means all those points which are common to S and S dash lie on this conic. So this is the equation of any conic which passes through the point of intersection of the conic S and S dash. So the equation hence S plus lambda S dash equal to 0 is the equation of any conic which passes through the common points of S equal to 0 and S dash equal to 0. So any conic which passes through, for example, this conic or this conic or this conic, any conic which passes through the point of intersection of these two conics, the equation of that conic is given by S plus lambda S dash is equal to 0. Alright, so this was the second part. Now we discuss another concept in the system of conics. That in how many points two conics intersect. Suppose we have one conic S equal to ax square plus 2hxy plus by square plus 2gx plus 2my plus c equal to 0. Suppose this is one conic and suppose a dash x square plus 2 s dash xy plus b dash y square plus 2 b dash x plus 2 f dash y plus c dash equal to 0. Suppose this is the other conic. So these conics can intersect at how many points? S equal to 0 is one conic and S dash equal to 0. So these conics can intersect at how many points? Alright. So from the first equation, if you consider y as a constant and find the value of x, So you get a quadratic equation in x. This is a quadratic equation in x. So if you solve this quadratic equation in x, you get two values of x in terms of y. Considering y as a constant, you get two values of x. Alright? In terms of y. And putting those two values here, you again get a quadratic equation which gives you two values of y. y1 and y2. Alright? Suppose from here you get, this is a quadratic equation in x. Considering y constant, this is a quadratic equation in x. So if you find two roots of this equation, one root is suppose x1 and the other root is x2. So if you put x1, the value of x1 in terms of y, here you get a quadratic equation which gives you two values of y, y1 and y21, and putting the value of x equal to x2 here in terms of y, you again get two values of y. You again get a quadratic equation in y. So in all, you get this will be 1 point, this will be second point, and third point, and fourth point. So there would be 4 points, the coordinates of 4 points, which would be the points of intersection of these two conics. These points may be real or imaginary. Okay, because the roots of the quadratic equation may be real, the roots of the quadratic equations may be imaginary. So in total, if two conics intersect, they intersect at 4 points. If two conics intersect, they intersect at 4 points, and those 4 points may be all real, or maybe some points are real and some points are imaginary. How do we found out? We solved this equation. Consider this as a quadratic equation in x, solve it for y, you get two roots of x, two values of x in terms of y. Putting one value of x in terms of y, here you get again a quadratic equation in y, which gives you two roots in y, and putting the second value of x, second root of x from here in terms of y, here you again get a quadratic equation y which gives you two values of y. So in total you get x1 y1, x1 y21, x2 y12, and x2 y22, 4 points, the coordinates of 4 points. These 4 points may be real or imaginary. So two conics intersect each other at 4 points. Two conics intersect each other at 4 points. The 4 points may be all real, or some points real and some points imaginary. So this is the second thing. This is another fact that we have learned about the system of conics. So two conics always intersect at 4 points. Now, if two conics intersect at 4 real points, two conics intersecting at 4 real points. Suppose one conic is s equal to 0 and one conic is s dash equal to 0. And suppose these two conics intersect at 4 real points A, B, C, D. Alright, 4 real points. Then it can happen that all the 4 real points are like this. Then we say that the two conics, the contact of these two conics is of 0 degree, 0 degree contact. Zero degree contact of two conics. Then we say that the contact is of 0 degree. This can happen that A and B may coincide. Alright, this is one conic and this is the other conic. A and B both coincide here, and then you have C and D. This may also happen. Alright, then we say that these two conics, the contact of these two conics is of first order. this is a point of contact of first order. This point is called point of contact of first order. Point of contact, one point of contact of first order. Here all the points are points of contact of zero order. All the points are points of contact of first order. In this case, this point is point of contact of first order, and also this may be the case that this point C also coincides with A and B. So it may happen like this. It may happen like this. That the point A, B and C all coincide here, and this is the point D. This kind of intersection can also be there. That the 3 points A, B and C all coincide here, and you have one point D here. So when all three points A, B and C intersect, they coincide at only one point, then we have the contact is of second order. Contact of second order. And this can also happen that the two conics may meet like this. So all the points A, B, C and D, they all coincide at only one point. All the 4 points coincide at only one point. Then this contact is called point of contact of third order. So this kind of point of contact is called point of contact of third order. This kind of point of contact is called point of contact of second order. And this kind of point of contact is called point of contact of first order, where two points meet. And this type of contact is called every point is point of contact of zero order. Alright, this is happening when two conics intersect at 4 real points. Two conics always intersect at 4 points. The 4 points may be real, the 4 points may be imaginary, or some points real, some points imaginary. But if all the points are real, if all the points of intersection of two conics are real, then we have the following 4 cases. The points of contact may be of zero order. We may have one point of contact of first order. We may have one point of contact of second order, or we may have one point of contact of third order. All right. And what is a double contact? All right. Double contact. When do we say that two conics have a double contact? So if you have one conic this and another conic is this, and you have 2 points coinciding with this point and 2 points of intersection coinciding with this point. All right. So if you have 2 different points and both the points are of first order, both the points are points of contact of first order. This point is point of contact of first order. This point is also point of contact of first order. So when two conics S equal to 0 and S dash equal to 0 intersect each other, and you have 2 different points of contact of first order, 2 different points of contact of first order, then we say that these 2 conics have a double contact. So we say that these 2 conics have a double contact if there are 2 different points of contacts of first order. Now next, Okay, so next we find the equation of a conic. Which has a double contact. With a given conic. Which has a double contact with a given conic. So suppose this is a given conic to us, s equal to 0. So this is a given conic, s equal to 0, and suppose we have to find the equation of a conic which has a double contact at these 2 points. We have to find the equation of a conic like this, which has a double contact at these 2 points. Suppose the equation of this straight line is u equal to 0. Alright. So then the equation of the conic which has a double contact with s equal to 0 is given by this equation, s plus lambda u square equal to 0. S plus lambda u square equal to 0. This equation gives us the equation of a conic which has a double contact with the conic s equal to 0. Right? For example, suppose s is this ax square plus 2hxy plus by square plus 2gx plus 12y plus c equal to 0, and suppose the equation of this line, is lx plus my plus n equal to 0. Then the equation of any conic which has a double contact with this conic at the 2 points where this line cuts this conic is given by let's do it here, is given by ax square plus 2hxy plus by square plus 2gx plus 12y plus c. This is s plus lambda times u. U is lx plus my plus n square. Put it equal to 0. S plus lambda u square equal to 0. This is the equation of any conic which has a double contact with the given conic. Alright, where the equation of this line is given, u equal to 0. So this was one thing, and then next is suppose we have 2 conics, this conic and suppose we have this conic. Suppose this conic is s equal to 0 and this conic is s dash equal to 0. Alright, suppose the equation of s is ax square plus 2hxy plus by square plus 2gx plus 2y plus c equal to 0, and suppose the equation of the other conic is a dash x square plus 2h dash xy plus b dash y square plus 2g dash x plus 2f dash y plus c dash equal to 0. Suppose you have these 2 conics, and suppose these 2 conics have these points in common. They intersect at these points. So what is the equation of the straight lines? What is the equation of a pair of straight lines which pass through these 4 points? So this is one pair of straight lines. This is one pair of straight lines which pass through these 2 points. Alright, and this is another pair of straight lines which passing through these common points, and this is the third pair of straight lines This is the third pair of straight lines which passes through these common points. So there is three pair of straight lines which pass through these common points. How to find the equations of these pair of straight lines? So what we do is any conic which passes through the points of intersection of this conic and this conic is given by s plus lambda s dash equal to 0. So this equation can be written as a plus lambda a dash x square plus 2x plus lambda h dash xy plus b plus lambda b dash y square plus 2g plus lambda g dash x plus 2 f plus lambda f dash y plus c plus c dash lambda equal to 0. So this equation, so the equation of any conic which passes through the intersection of these two conics. So equation of any conic which passes through these 4 points is given by this. So if this conic represents a pair of straight line, if this conic represents the equation of a pair of straight lines, then delta must be 0, and that means ABC plus 2FGH minus AF square minus BG square minus CH square is 0. This implies ABC this ABC plus 2FGH minus a f square minus b g square minus c x square equal to 0. So these are two conics and these conics intersect at these 4 points. The equation of any conic which passes through these 4 points, the point of intersection of these two conics, is given by this. This equation is equal to this. And if this equation is the equation of a pair of straight lines, then this condition should be satisfied. This condition should be satisfied. And this condition, this is a cubic equation in lambda. This is a cubic equation in lambda, equation of degree 3 in lambda. So this has 3 roots, lambda 1, lambda 2 and lambda 3. Putting lambda equal to lambda 1 in this equation, you get one equation of pair of straight lines. Putting lambda is equal to lambda 2, 3, lambda is equal to lambda 2, you get the equation of the second pair of straight lines. And putting lambda is equal to lambda 3 in this equation, you get the equation of the third pair of straight lines. So this way you will find the equation of pair of straight lines which pass through the points of intersection of these two conics. And note that this cubic equation will have at least one real root. Alright, because the complex roots occur in conjugate pairs. So if this equation has 3 roots, then at least one of the roots must be real. So since at least one of the roots must be real, so that means there would be at least one real pair of straight lines which would pass through the points of intersection of these two conics. From the points of intersection of these two conics, there would pass at least one real pair of straight lines, because this equation will have at least one real root. So this was the pair of straight lines, and next we have about rectangular hyperbolas. If this is the equation of a rectangular hyperbola, if this is the equation of one rectangular hyperbola and this is the equation of another rectangular hyperbola. Rectangular hyperbola means what? Rectangular hyperbola means that if you have a hyperbola like this, then you know that these are the asymptotes of the hyperbola. These are the asymptotes. If this is a hyperbola, then these two lines are the asymptotes of the hyperbola. If the angle between the asymptotes is 90 degrees, then we say that the hyperbola is a rectangular hyperbola. So if this is and how do we check that this is a rectangular hyperbola? If this is the equation of a rectangular hyperbola, then a plus the coefficient of x square plus the coefficient of y square must be 0. So a plus b must be 0. Similarly, if this is the equation of a rectangular hyperbola, then the coefficient of x square plus the coefficient of y square must be 0. This is how we check whether this hyperbola is a rectangular hyperbola or not. The coefficient of x square plus the coefficient of y square, that sum should be 0. If this is a rectangular hyperbola and this is another rectangular hyperbola, then any conic which passes through the point of intersection of these two rectangular hyperbolas, any conic which passes through the points of intersection of these two rectangular hyperbolas, its equation would be this. This is the equation of any conic which passes through the points of intersection of these two rectangular hyperbolas. And this equation is equal to this. And in this equation, if this is a hyperbola, if this conic is a hyperbola, then you observe that the coefficient of x square plus coefficient of y square, the coefficient of x square plus the coefficient of y square is equal to this, and a plus b and a plus b is 0 because this hyperbola is a rectangular hyperbola. This is 0, and a dash plus b dash is also 0 because the second hyperbola is a rectangular hyperbola. So this plus this is 0, and that means the coefficient of x square plus the coefficient of y square in this equation is 0. That means this hyperbola is also a rectangular hyperbola. So any hyperbola which passes through the intersection of two rectangular hyperbolas is also a rectangular hyperbola. Any hyperbola which passes through the points of intersection of any two rectangular hyperbolas is also a rectangular hyperbola. So that was the third part, and that is the end of everything that we wanted to discuss in the system of conics. I'll give you a set of exercises to do in the channel video. Thank you.